US Physics Olympiad, year 2022. F equal MA, first round. Exam B. This year Olympiad was split by two exams, A and B, and all students could participate in any of these exams. As usual, it was given 75 minutes for 25 problems. Please subscribe for this channel if you want to get more interesting problems. Problem number 1. A ball is held a height h above a slope, which is at an angle 45 degrees from the horizontal. The ball is dropped from rest. Assume the ball bounces off the slope perfectly elastically. What is the distance between its first and second impact points? Solution for problem number 1. First, let's draw the picture. From this picture we can see that height is h, and for this height the first time to travel will be t0 equal square root from 2h over g. It means that for the second impact it takes 2 times t0, which is 2 square roots from 2h over g. Now let's count what is the speed of this ball right before the first collision. That will be vertical speed equal square root from 2gh. After bounce it turns in horizontal direction, and we can count what is the horizontal distance for the motion between two impacts. That will be x equal vt or 4h. And last step is to find the distance. Distance will be square root from 2x or 4 square root from 2h. That's answer D, and that was solution for problem number 1. Problem number 2. A massless wheel of radius r has 4 small masses m placed evenly along its rim. Let the moment of inertia for rotations about the center of wheel and the plane of the wheel be I0. Now consider rotations about the two axes shown, with the corresponding moments of inertia I1 and I2. Which of the following is true? Solution for problem number 2. By definition of moment of inertia, we have I0 equal 4 times mr square, I1 equal 2 times mr square, I2 equal 4 times mr over square root from 2 square, which is 2 times mr square. It means that we have I1 equal I2 equal I0 over 2. That's answer A, and that was solution for problem number 2. Problem number 3. 4 evenly spaced points are marked on a massless seesaw as shown. 2 blocks of masses 5 kg and 7 kg are placed on the seesaw so that it balances when the fulcrum is at point 4. The diagram is not drawn to scale. Now suppose the fulcrum is moved to point 2. How much mass should be placed at point 1 so that the seesaw again balances? Solution for problem number 3. If the seesaw was initially balanced, its center of mass must have been directly over the fulcrum. Therefore, the total weight force of 120 newtons can be regarded as acting at point 4. After the fulcrum is moved, balancing torques about 0.2 implies that the new mass should have a weight of double of this 120, which is 240, because distance from point 2 to point 4 twice greater than distance between point 2 and point 1. So it means that total mass must be placed twice greater, which is 24 kilograms. That's answer C, and that was solution for problem number 3. Problem number 4. A firework explodes, sending shells in all directions in a vertical plane as shown. Suppose the shells are all launched with the same speed and ignore air resistance but not gravity. A long time later, but before any of the shells hit the ground, what shape do the shells make? Solution for problem number 4. In the absence of gravity, the shells would always form a circle. Adding gravity simply shifts all of these locations downward by gt²/2. So the shape is still always a circle, which is answer A, and that was solution for problem number 4.